Hello, guys. Welcome back to Maths Zone African Motives. We are still on our revisions, working with our grade 9 mathematics. So, we are given the March test, which was written in 2025. So, we are going to use previous exam papers or previous question papers for revisions. All right. So that was from the KZN province. And without wasting our time, guys, we're given this. It was 50 marks and to be written in 1 hour. The duration is 1 hour. So make sure you read the instructions, all right? All instructions that you are given, all right? So that was the major part where we are given. This question paper consists of 5 questions. Answer all questions that you're given. Clearly show all calculations that you have used in determining your answer. So you must show all calculations that you have used in what determining your answer. Answer questions 2 to 5 in the spaces provided. And all right, just make sure, guys, you're given an approved scientific calculator, non-programmable or non-graphical, may be used. So you can use what? A scientific calculator, which is not part of these two. All right, unless stated otherwise. So they might indicate that do not use a calculator on that question. All right, but when you are not told about that, the calculator can be used, and you can use that to verify your answers as well. All right, we had the section A, question number 1, which we are given 10 marks for that. All right, by the way, you can download the question paper and also the memo if you check the description of the video or in the comment section. All right, you're going to see that comment where you can download the question paper so that you can properly see. Some they want to print out and have a hard copy. It depends with the way that you use when you are studying. So you can download the question paper. All right. So I'm not going to waste your time, guys. We are given here 4 options are provided as answers to the following questions. Circle the letter corresponding to correct answer. You must circle the what? The letter that correspond to the correct answer. 1.1. Which of the following numbers is an irrational number? Which one is an irrational number? Remember, irrational numbers, we are referring to those numbers that are endless decimals, all right? And endless decimal, all right? Where, in actual sense, we cannot write those endless decimals as fractions. We cannot write them as a over b, as a fraction a over b. All right, we cannot write that in that format. This does not exist for irrational numbers. So we are talking about pi, we are talking about square root of numbers, square root of 3, square root of 7, something like that. Those are irrational numbers, remember? So the best answer was going to be C, the square root of what? The square root of 5. But if you were to consider the others, we are given a 1.7 with a dot like this. This means you are given a recurring decimal. A recurring decimal. A recurring decimal is part of rational numbers. All right. It can be expressed in the form a over b. All right. That one, you are going to have it in your grade 10. all right, where you are going to be given to express this as a fraction a over b like this. That is as a what? As a rational number. So this one, it is a rational number. The cube root of minus 8, all right? The cube root of minus 8 is what? A negative 2. The cube root of minus 8, it is minus 2. And minus 2 can be written in the form of what? A over b. Same as minus 2 over 1. So you can see that it is what? A rational number. So we are not going to take this. All right. Then on D, we have the square root of this. All right. The square root. Sorry, let's just put the square root. Then I'm going to put shift and press this fraction. So that's 1 and 7 over what? Over 9. This is going to give us 4 over 3, which is in the form a over b, a rational number. So this is not irrational. So the only one was going to be the square root of what? Of 5, which is c. All right. On 1.2, 216 as a product of its prime factors. We talk about what? Prime numbers. Remember, the smallest prime number is 2, followed by 3, followed by 5, 7, 11. So as a product of what? Prime numbers. 216. Simply do this. But this was section A, where the answers are already there. You can use the ladder, all right, which is okay. But also you can just use a calculator. This is what you do. 216 is equal to, all right, then you press this shift, then you press fact, shift, and you press fact on these dots here. All right, so let's do that. Shift, then we press these dots, these ones on what? On fact. This is what? 2 to the exponent of 3 times 3 to the exponent of 3. We have the answer already. 3 to the exponent of 3. We have the answer already. Here we are given as a product 2 times 2. So 2 to the exponent of 3 means 2 is multiplying itself what? 3 times, which is what we have here, 3 times. And the 3 is multiplying itself what? 3 times. So the answer is what? Is A. You could have just simplified that on your calculator. But anyways, that's not the only option. We have the ladder, remember? So you're going to divide by the smallest prime number, which is 2. We have got a 6 here, so we're going to use a 2. Divide by 2. 216 divided by 2 is going to give us what? 108. All right. Again, we can use what? A 2. Divide by 2. 108. All right. Sorry, we're just going to divide by 2. That is what? 54. All right. Again, we can use a 2. 54 divided by what? By 2. This is going to give us 27. So this time we cannot use a 2, guys. All right. 2 is not a factor of what? 27. But 3, it is a factor of what? 27. So we're going to use 3. Divide by 3, 27. Divide by 3, that's a 9. Again, 3 is a factor of 9. So 9 divided by 3, that's a 3. 3 is a factor of 3. So 3 divided by 3, that's what? That's a 1. So until you obtain a 1, you are done. So this is 216, which is a product of 2 times 2 times 2. We have 3 and 3 and 3. So that's times 3 times 3 times 3. So this is what we have exactly the same thing. So you could have used a calculator, or you can use the ladder diagram to simplify that. Let us consider 1.3. Calculate. All right. So here we are given so many indications that we can apply. Positive, there's addition, there's subtraction, multiplication, so many operations. So we can apply the body mass. Some they use bombdas. It's one and the same. So meaning to say division, multiplication, or multiplication division can be done at the same time. Because who is using someone who is using BODMAS is going to use or to apply division first, then multiplication. The one who is using this BOMDAS is going to use multiplication, then division after. So this one is anyone, any part. Multiplication and division is in your hands, all right? So that is the brackets, all right? Do not consider this as a bracket, all right? It's a bracket, of course, but it is just an indication of the sign to say the 2 that we have carries a negative. There was no need of even putting this bracket. So these are not the brackets that we're talking about. When we consider these brackets, we're talking about something like minus 2 times 2 or minus 2 plus 2 in a bracket where you must simplify what is inside the bracket. But here there's nothing to be simplified. It is just for a sign. So this is what I'm trying to say. Division and multiplication. Let us apply these two at the same time. So there is a division here. There is a multiplication here. So we are going to apply this at the same time. So this is what I'm trying to say. We are going to have 6, all right? 6 plus 6. This is a positive 6 divided by 2. 6 over 2. That's a 3. All right, so it's going to be plus 3. Take note of the sign, plus 6. So it's plus over a plus. All right, then here it's a product. Minus 6 times minus 2. Minus 6 times. So minus and minus is going to give us a positive. 6 times 2, that's a 12. So this is the idea that you're going to use. All right. So here's just addition. Simply add everything. 6 plus 3, that's a 9. 9 plus 12, that's what? That's 21. You can even use your calculator at once. 6 plus 3 plus what? 21. So that's a 30. Sorry, 6 plus 12. Sorry, we're not 21, but what? 12. This is, I'm still writing 21, guys. That's a 21 at the end as our final answer. We can also verify this. That's the importance of using a scientific calculator. We can verify this whole part as it is 6 plus 6 divided by 2 minus 6, all right, times a negative 2 like this. As it is, you can see that 21. All right, so the best answer was going to be A, which is what? 21. Then on 1.4, we have got the same concept here. Same concept on 1.4. That is application of the BODMAS again, or BOMDAS. So if we are to consider this time, we've got brackets. We can see that this part under brackets has to be simplified on its own. So we need to consider brackets off. So that's 8 times what is inside the brackets. This is minus 9 plus minus 7. We are adding a negative to a negative 9. So simply add these two, all right? Then use the common sign. Just add 9 plus 7. That is what? 16. And use the common sign on your answer, which is the negative. Or simply from your number line, negative 9 minus 7, you're going to the left. So we end up at negative 16. So that's times negative 16. All right, or you can just use your calculator to verify that. Then the product of these two, that's 8 times 6, which is gonna give us 48. All right, so we're gonna remain with a 4. 8 times 1, that's 8 plus 4, that is gonna give us 12. And we've got a negative there. So that's negative 128, which is what? Which is A. All right, 1.5 we are given. Again, all right, this is we're going to apply again our BODMAS. But let's simplify first. There's what is the square root of 36? This is what? 6. 6 times 6. 6 squared gives us what? 36. Minus the square root of 4. That is 2 times 2. The number that is going to multiply itself to give us what? A 4. That's a 2. The cube root of 125. That is a 5. All right. You can also verify on your calculator the cube root of what? 125. If you do not know your answer, just use the calculator to verify that. All right. So like I said, the BODMAS, we do not have brackets. Division, we have got a multiplication. So these two here are under multiplication. So we're going to multiply these two together. 6, all right, minus 2 times a 5. There's a positive. So minus times a positive, that's a negative. 2 times 5, that's a 10. So you are going to subtract 6 minus 10, which is what? Negative 4. And we do not have negative 4 on that part. So in our case, there is no option here. We do not have that. All right, let us just verify on our calculator direct the square root of 36. All right, move aside, minus the square root of 4. You move aside again. Sorry, here. Then times the cube root. You're going to press shift and you press the square root. So that's the cube root of 125. As it is here, this is going to give us a negative 4. Exactly what we obtained, but that answer is not given. So there is no option. It was just going to be free marks for that. All right. 1.6 complete. All right. What is it that we must do here? All right. The bracket concept. So take note, when a negative is raised to an even power, it's going to be a positive. When it is raised to an odd power, remember I told you guys it's going to remain as a negative. So 3 is an odd number. So minus, when raised to the exponent of an odd, is going to remain as a negative. But each and every term here has to be raised to the exponent of 3. 2 to the exponent of 3. All right, that is 2 times 2 times, which is going to give us 8. P to the exponent of 3 is also raised to the exponent of 3 like this. So remember the concept, guys. X to the exponent of m raised to the exponent of n is going to give us x to the exponent of mn. You multiply the exponents. So here you're going to multiply your exponents. 3 times 3, that is going to give us a 9. All right, so that's p to the exponent of 9. Then t is also raised to the exponent of 3. So that's t to the exponent of 3. So which one is it that we have here? Minus 8p to the exponent of 9 to the exponent of 3. That is on what? On B. So the answer was going to be B. All right. 1.7, the number that we are given here in scientific notation, writing as a number between 1 and 10. So we must have it in the form a times 10 to the exponent of n, where a, remember, is a number between 1 and 10, greater than or equal to 1, but less than what? Less than 10. And n can be any integer. All right, what am I doing here? Our n is an integer, positive or negative. So when you are given these decimals 0, 0, once you have got 0, you know that your exponent is going to be negative. So let us just make this number to be between 1 and 10, in between. So it must be less than 10. Less than 10. So you're going to move the comma to the right. 1, 2, 3, 4, 5, 6 until we are at 1,44. So it's going to be 1,44 times 10 to the exponent. Remember, we moved the 6 decimal, 6 commas. We moved 6 commas going this side. So it's going to be -6. The reason being, you started this number is starting with what? A 0. Once you are having this starting with a 0, the exponent is going to be negative. So the best answer was D. All right. In the sequence 258, the next three terms are what? In this sequence, if we are to study it properly, we are going to see that there is a difference of 3 throughout. 5 minus 2, that's a 3. 8 minus 5, that's a 3. Meaning to say we are referring to a linear sequence, right? A linear, where there's a difference, a constant difference. There is a constant difference. So to find the next term, you simply have to add that constant difference. So to find the next term, 8, you add 3. 8 plus 3, that is what? That is 11. So we've got the next term. But they said next 3 terms. So you have to find another one. We add that constant difference. 11 plus 3 is going to give us what? 14. That's another term. And the third one, because we've got 1, 2, we need the third one plus 3 again. 14 plus 3, that's what? 17. So we need 11, 14, 17. And that was on what? On A. 11, 14, 17. These are the next 3 terms. You just have to add the constant difference. And as we can see here, 1.9, in the sequence, the rule for the pattern is, all right, if we check here also, that's a constant difference here. 8 minus 3, that's 5. 13 minus 8, that's 5. This one, that's 5. So we've got a constant difference again. So meaning to say we are dealing with a linear sequence or a linear pattern, which the rule is given by Tn is equal to, all right? So here, guys, you're going to write the way that you want. You're going to write dn plus c. You're going to write bn plus c. You're going to write an plus the way that you understand, as long you understand that the coefficient of n, this one, is our constant difference. That's our constant difference. So we already have this one as what? As a 5. The constant difference here is what? Is 5. So Tn is equal to 5n in place of b, the constant difference. You substitute that constant difference, all right? Plus c. So c is the constant to be calculated. And I told you guys to determine this, you use the terms that you are given. This is the first term, the second term, the third term, and so on. You just take any one which corresponds. I'm just going to use the first term. As for me, guys, I just use the first term. T1 is equal to what? The first term is equal to 3. What does it mean? Tn, n is represented by what? By 1. N there. It was supposed to be Tn, but we write what? 1. So it simply means when n is equal to 1. N, this one, 1. This is your n. So in place of n, you are going to substitute 1. Tn. When n is equal to 1, T1 will give us what? A 3. So in place of n, where you see n here, 5n, that means your n is what? Is 1. So that's 5 times 1. Our n is 1. Tn, the whole of this Tn, T1 is 3. In place of n, it was going to be T1. In place of n here, it was going to be T1. But T1 is equal to what? It is equal to 3. So you substitute a 3 in place of that Tn. T1 is 3. So you can solve for C. Find the value of what? Of C. Solve for C. All right, we are back to our equations in what? In grade 8. So that's 3. 5 times 1 was going to be 5. Then you take it to the other side. So that will be a negative what? A negative 5, which is equal to C. 3 minus 5, that's minus 2, which is equal to C. So C is equal to minus 2, meaning to say, in place of C in this equation or on this part of our equation, it simply means we are going to substitute our C here, which is what? A negative 2. So that's plus minus 2, which is what? Minus 2. So this is our Tn. And the best answer, having 5n minus 2 was going to be what? Was going to be C. There are so many ways, but this is the basic or the way that where it was originally taken from. So you can have other shortcuts, which is okay. But that is it. 1.10. In the pattern below, the next diagram will have how many black tiles? The next diagram. All right. Let's look into our diagrams that you're given. This is the first diagram. How many black tiles? Black. That is 1, 2, 3, 4, 5. There are 5 of them. All right. The second one, how many black tiles? All right. We have got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. The third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 of them. So what will be the number of black tiles in the next? So guys, here it was just a matter of looking into the pattern that is being formed from the black tiles. The first part was having 5. Second one, 8. Are we seeing that there is a constant difference throughout? And we worked with this one with 5, 8, 13, if you still remember. We worked with something like that. Let me just bring you back a little bit. All right. Sorry for that. I think it's here. But we just had, it was this one, or this one is 3, 8, 13. This one is 5, 8, 13. All right. It has a difference. This one, he has got, it is different from that one that we had. The last part that we had, that was a 3, but this one, it's a 5. So if we check, what is the difference if we are to consider the difference between the terms? 8 minus 5, that's a 3. And 13 minus 8, that's what? That's a 5. So if we are to consider, guys, this one, it is not about the constant difference. The difference is not the same. The difference is not the same. So what actually happened here? To say the first part, we had to add a 3 to get this 8. But the second part, we had to add a 5 to get 13. What about the next one? Now, what are we supposed to add? Because these numbers that are being added are different. They are different. It was 3 in the first place. It was a 5. So if you check the numbers that are being used, they are simply having a difference of 2. 5 and 3 have a difference of 2. So it means here we added a 2 to get a 5. So to get the next one, we must add a 2. That will be a 7. So meaning to say 7 was supposed to be the difference between the term that we want and 13. So to obtain that term, we must add a 7. So 13 plus 7 was going to give us what? Was going to give us a 20. So that's the next term that we are going to have. There will be 20 tiles from that. So it is a certain type of sequence which is to be done later on in grade 11 when you do what are referred to as quadratic sequence. It is actually being taken from a quadratic equation, just like a quadratic presentation. Remember, I've got a linear. So that is where it was actually being taken. But as of your level, guys, once you see this, you can also answer this question to say, here 3, remember it's a prime number, this one. 5 is also a prime number. Remember the sequence of your prime numbers: 2, 3, 5, 7. So someone can just say it was just prime numbers that were being used. We added the 3, the first, 2 was not included in that case because remember, there can be other numbers before. But starting at the 3 here, we can see that here we added a 3, then we obtained 8. From 8, we added a 5 to get a 13. So from 13, what must we add? We must add a 7 to get a 20. So someone can use that concept to say there are prime numbers that are being used here: 3, 5, 7, and so on. Meaning to say what follows after 7 is what? 11. All right, someone can consider as prime numbers, which is something that is what can you say, it is in between in terms of how you study that sequence. It is in between in terms of how you study the sequence. But in a proper presentation, this is supposed to be what? You're supposed to find other differences from there to say, all right, what is actually happening on these differences that I'm having? There is a difference of 2. So meaning to say here also there was going to be a difference of 2. So 5 plus 2 is going to give us what? Is going to give us a 7. That 7 is the one that you're going to add on 13. So yeah, if it is a quadratic, you must be very careful. It is like that in many ways where it just complicates one or two things. But don't get lost, guys. Just follow the concept. It is just a repetition that you see. All right, on 2.1, which was part of our section B, working with question 2. 2.1, you are given 2.11. Which one is the smallest natural number? Remember, natural numbers are actually counting numbers, these ones. These are counting numbers, but excluding what? Excluding 0. Excluding 0. 0 is not included. So meaning to say, we were supposed to have a 0, but it's no longer there. But we are talking about counting numbers: 1, 2, 3, 4, 5, and so on. So the smallest is going to be what? Is going to be a 1. And which one is the smallest prime number? Prime numbers: 2, 3, 5, 7, 11, and so on. The smallest prime number is what? Is 2. Exactly divisible by what? 1 and itself. That is the idea of what you are going to have on that part. So you just have to consider that idea. All right. Let us move on to 2.2. Determine the HCF and LCM of these using prime factorization. All right, that's our 2.2. So let us just express these ones as product of their prime factors. 84, the smallest prime number, that's a 2. 84 divided by 2, that's 42. We can divide by 2. 42 divided by 2, that's 21. 2 cannot work here. Let's use 3. 21 divided by 3, that's a 7. 7 is a prime number, so definitely we're going to use a 7. 7 divided by 7, that's a 1. All right, so that's 84. And 96, in the same manner, the smallest is going to be 2. 96 divided by 2, that's 48. Then divide by 2. 48 divided by 2, that's 24. Divide by 2. 24 divided by 2, that's a 12. Divide by 2, that's a 6. Divide by 2, that's a 3. 3 is a prime number, so it's going to be 3 and gives us a 1. All right, so these are the prime numbers that we are going to have, and we are being asked to determine the HCF, which you can just look into the table as it is, or you can write your numbers as product of their prime factors in exponential form, or as they are like this, as they are these numbers, that's 2 times 2, 2 squared, times 3 times 7. Then, oh, sorry guys, why am I writing HCF? That's 84 here. 84 is equal to this. 96 is equal to 2 to the exponent of what? That's 1, 2, 3, 4, 5 times 3. All right. So the HCF, we do understand that this one is the highest common factor. That's a factor. It must be common throughout. And where you have got exponents like this, you must take the one that has got the smallest exponent where it is common. You must consider where you've got the smallest exponent. So the first thing is that it must be common. 2 is common throughout. But which one has got the least or smallest exponent? 2 to the exponent of 2. 3 is common throughout, and it is of the same exponent. So we're just going to write as it is. Do not repeat. 7 is not common. We do not have it here. So we cannot take that on the HCF, all right? So 2 to the exponent of 2, that's 4 times 3, which is what? Which is going to give us a 12. So that is our highest common factor. Whereas the LCM, since it is a multiple contains all terms, all numbers that you see here. But we must consider where it is common, you take the highest exponent, the one that has got the highest exponent. Where it is common, like 2, we also have a 2 here. So we're going to take the one with the highest exponent. There is a 3, there's a 3 here. We're just going to take the 3 as it is. There is a 7. We do not have it on this part, but since it is a multiple, it consists of every term. That 7 has to be part of your answer. All right, so that was it. 2 to the exponent of 5, that's 32. 32 times, all right, you can just use your calculator here, guys. 3 times 7 is 21. Then you multiply, this was going to give you 672. So that's our lowest common multiple. All right, so do revision, guys. Just go through the introductions where I introduced these topics so that you can understand much better. All right. On 2.3, the distance between Centon and Pretoria is 42 kilometers. All right, so we have the first part here of what? Of Centon and what? To Pretoria. All right, so the distance is given as 42 kilometers. All right, and the how train covers, the train that is moving there covers this distance in 11 minutes. We are given the time in minutes, so we must express it in hours. Since the distance is in kilometers, simply divide by 60. Your answer will be in hours. All right, if the average speed remains the same, if the average speed remains the same, meaning to say the speed that we are going to have here is the same as the speed that we are also going to have on another part where they are referring between Pretoria and Kempton what Park. How long will it take the Gautrain to cover that? To cover these two. We are now talking about what? Pretoria to Kempton Park. This is what we have now, which is 51 kilometers apart. The distance is 51 kilometers. We do not know the time. We are asked to, how long? What is the time? Leave your answer in hours. So we need the time in hours. So remember that what we only have between these two that is the same, it is the speed. If the average speed remains the same. So what you're going to do is to calculate the average speed from this side. So if you check your memo, it made a mistake on the time. They used 0.5 hours. No, 11 minutes. It means in hours, it's 11 over 60. That's not 0.5. All right. It's an endless decimal that you're going to have. So they just made a mistake on that one. You must correct. So we can use our DST to find the speed on this first part between Centon and what Pretoria, because we have got what distance and time. So speed can be calculated. Remember, speed is our common value that we are going to apply. So speed is equal to what? Distance over time. So that's distance over time. Our distance, 42 kilometers over our time, 11 over 60, like this. So it means our speed was going to be 42 times. Remember, the moment we introduce a multiplication here, we invert the second fraction. So it's going to be 60 over 11. So that's 60 over 11. So that's our speed. All right. 42 times 60 over what? 60 over 11. That was going to give this. And as a decimal, that's 229.09. All right. 229.09 to 2 decimal places. Kilometers per hour. It will be kilometers per hour, the speed, since we used distance in kilometers and our time is in what? In hours. So that's kilometer per hour. So remember that we are told that the speed is the one that is what? The same. So it means when this train is moving from Pretoria to Kempton Park, it is going to be traveling at the same speed of what? 229.09 kilometers per hour. What is going to be the time in hours? So the time can be determined as we now have what? As we have got distance and what? Distance and speed, right? Sorry for that, guys. Kilometers per hour. So as we have got the distance and the speed, time can be determined, which is how long will it take the train, the train to move or to cover Pretoria and what? Kempton Park. So that is now we can determine our time. So time is what? Time is distance over speed. Time is distance over speed. In hours. Kilometers per hour. So our time is going to be in hours. So that's 51. Our distance, 51 kilometers over the speed, 229.09. So that is going to give us the time in hours. All right. So that's 51 divided by 229.09. So this is what you're going to have to 2 decimal place. That's 0.22 hours. So let us correct that part of our memo because they used the wrong time. So that is going to affect our answers at the end. So this is what you're supposed to have. 11 minutes, it is what? 11 over 60 in hours. You divide by what? By 60. Let us consider another part, question number 3. Without using a calculator, that is the first part we are told not to use a calculator. 3.1, we are supposed to calculate this, all right? Minus 50 plus, let's consider the brackets from our board mass. The brackets here, inside the brackets, minus 50 plus 14. It means we are going to the right, sorry, plus 14, that's a positive to the right. So what you simply do is to subtract these two, 50 minus 14, then you use the sign of the bigger number. So it was going to be 36 times 50 minus 14, that's 36, but you're going to take the sign of the bigger number, it will be negative 36, all right? Remember when the signs are different like this, subtract the smaller number from bigger number, then you use the sign of the bigger number. If they were the same, you add them, then you use the common sign on your answer. Different, subtract, use the sign of what? The bigger number on your answer. So here, multiply 36 times 36. That's going to be 0 here. 3 times 6, that's 18. 3 times 9, 3 times 3, that's 9, plus 1, that's a 0. 6 times 6, that's 36. 6 times 3, that's 18, plus 3, that's 21. Then add the 6, 9, 2, 1. So it was going to be negative 1, 2, 9, 6. Positive times negative is what? It is a negative, all right? So that's a basic calculation, guys. Know your multiplication from your grade 8. All right. Negative, and there's also a negative here that will give us a positive 4. All right. So that's positive 4 times negative 2. So a positive times a negative, that's a negative. 4 times 2, that's 8. So that was going to give us negative 8. All right, on this one, we had the product here, both mass. We have to consider product of these two. Minus 2 times 3, that's negative 6 plus 7 over what? 18 divided by 0 minus 6. 0 minus 6, that's a minus 6, all right, times negative 3. So let's consider addition. Minus 6 plus 7, the signs here are different. So that's 7 minus 6, which is 1. You take the sign of the bigger number, which is what? A positive. So that was going to be 1 over what? 18 over minus 6. That's positive divided by negative. That's a negative. 6 into 18, that's a 3 times negative 3. So this is where we are. Negative, 1 over minus 3 times minus 3 is same as minus 3 over 1. So you can simply divide this, cancel minus 3 in the numerator, minus 3 in the denominator. So you're going to be left with 1 over 1, which is what? Which is 1. So the whole of this part, guys, was going to give us a 1. All right. Yeah, they can play around with that. They can play around with that, which is good revision. Just do more questions, guys. All right, on 3.4, this is 5 times the square root of 100 divided by the cube root of 8 over what? The square root of 15 plus what? 15 plus 10, everything under the square root. All right, so this was going to give us 5 times the square root of 100, that's a 10, divided by the cube root of 8, which is 2, everything over the square root of what? 15 plus 10, that's 25. And the square root of 25 is what? Is 5. So this is where we are. Remember, board mass, I told you guys there's a part where we consider division, division and multiplication at the same time. It depends with what you're using. So if I'm using board mass, I'm going to divide these two together. 10 divided by what? By 2, which is 5. So it's going to be 5 times 5 over 5. That is what it means. 5 times 5 over 5. So here, guys, I can simply cancel 5 and 5. So I'm going to remain with what? I'm going to remain with a 5. Or you multiply 5 times 5 is 25 over 5. That was going to give us a 5 as well. All right, just like that. Simplify the following. That's question number 4, which had 11 marks. Simplify the following and leave your answers with positive exponents. Positive exponent, all right? So here, guys, multiplication of the same base. Remember that you add the exponents m plus n. So here it is p and p. We're simply going to add our exponents 3 and what? 3 and 2. So that's p to the exponent of 3 plus 2, which is 5. All right, you add your exponents. You add the exponents from the same basis under a multiplication. All right, 4, we still have the same thing here on 4.2. A multiplication again, so that's a 1 here. 3 times 1, that's a 3. A to the exponent of minus 3 times a to the exponent of 2, you add. Minus 3 plus 2, that's what? Minus 1. So a to the exponent of minus 1. B to the exponent of minus 2 times b to the exponent of 4, you add again. So that's minus 2 plus 4, which is what? Which is 2. So they told us to leave our answers with what? Positive exponents. Here, if we are to consider on our question, there is a negative exponent. How do we get rid of a negative? All right, 1 over x, it is from x to the exponent of minus 1, or 1 over x to the exponent of n from our laws of exponents. So meaning to say, wherever we have got 1 over, we are going to write it as, as long we've got a negative exponent, it's going to be 1 over that. A to the exponent of 1, which is a, times b squared. So this is just like multiplying the numerators together. 3 times 1 times b squared. So it was going to be 3b squared over what? 1 times a times 1, that's a. So that is how you can write your answer as 3b squared over a. All right, and on this one, it is still the same thing, multiplication of same bases, but we've got numbers 3 times 4, that's 12. B and b, you add the exponents, so that's 3 plus what? 3 plus 4, which is b to the exponent of 7. Over what? You do the same thing here, minus 2 times minus 3. Minus times minus, that's a positive. 2 times 3, that's a 6. B to the exponent of 2 and b to the exponent of 8, you add 2 plus 8, which is what? B to the exponent of what? 10. So this is just a division. 12 divided by 6, that's a 2. This time we are dividing the same bases, so we must subtract. Division of same bases, you subtract your exponents. So that's b to the exponent, that's 2b to the exponent of 7 minus 10. You have to subtract, which is 2b to the exponent of minus 3. Remember, how do you remove a negative, guys? We talked about this. It is 1 over that, b to the exponent of 3. So this is 2 over 1. 2 times 1, that's 2. 1 times b cubed, that's b cubed. So you can write your answer as this. Just like that. So simplification, guys, just follow the way that you understand, but at the end, you must have an answer like this. All right, solve for the unknown. All right, that's an equation here. We are back to our exponents. So let us just try to write them in the same base. 1 over 16 is same as 16 to the exponent of negative 1. But in the base of 2, in the base of 2, this 16 is 2 to the exponent of 4. But there is a negative 1 already. So you're going to multiply this and get what? A negative 4. Why are we writing this in the same base? It is because if we've got same bases like this, and they are equal, like same bases, it automatically gives us that a is equal to b. Exponents are also the same. So in the base of 2, it means, therefore, this part of our exponent, x plus 3, will be automatically equal to what? Minus 4. So what is the value of x? All right, let us solve this. 3 to the other side was going to be a negative, all right, or simply subtract 3. Minus 4 minus 3, that's what? Minus 7. Remember, minus 4 minus 3, we are going to the left, or simply add the numbers and use the common sign on your answer. So that was our value of x. Write down the next 3 terms of this sequence. All right, we had a sequence like this before that had 3, 8, and so on, which had a difference of what? Of 5 and 5. Actually, we had this before. So we're simply going to add what? 5. 18 plus 5, that's 23. 23 plus 5, that's 28. 28 plus 5, that's 33. So those are the next 3 terms, 23, 28, 33. Since there's a difference of 5, you just have to add that difference throughout. Study the table below and fill the missing values. That's the triangle. And value says just like writing the number here to say how many. That's one. Here it's 1, 2, 3. 1, 2, 3, 4, 5, 6. Here there are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So that was it. And here it is just a formula. So you cannot, guys, know how many of them are you going to put there. So it was just going to be 1, 3, 6. Just like that. All right. Study the design. How many shaded rectangles are there in design 5, 6, and 7? How many shaded rectangles? The first design, there are 2 of them. The second design, 1, 2, 3, 4. There are 4 of them. The third design, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. That is what we have on the third design. So what is actually happening here in terms of these numbers? 2, 4, 8. 2, 4, 8, guys. These are exponents. These are exponents of 2. Like first one, 2 to the exponent of 1. All right? Like the first one, these are like 2 to the exponent of 1. It gives us a 2. 2 to the exponent of 2, the second one, it gives us a 4. 2 to the exponent of 3, the third one, it gives us 8. So what does it mean about the fourth one? It was going to be 2 to the exponent of 4, which was going to give us a 16. The fifth one, 2 to the exponent of 5, which was going to give us 32. The sixth one, 2 to the exponent of 6, which was going to give us a 64. The seventh one, 2 to the exponent of 7, which was going to give us 128. So those are the next number of what? Rectangles. In terms of our rectangles, it is just 2 to the exponent, the pattern number that you're given. Pattern 1, pattern 2, pattern 3. 2 to the exponent of 3, 2 to the exponent of 4. So here they are asking about how many shaded rectangles are there in design 5, not 4. This is 16 is for design 4, where you raise 2 to the exponent of 4. But for design 5, it's going to be 2 to the exponent of 5, which is what? 32. There will be 32. For design 6, 2 to the exponent of 6, which is what? 64. For design 7, 2 to the exponent of 7, which is what? 128. So those are the ones that you're going to have. And determine the number of shaded rectangles in design n. Remember, guys, it is 2 to the exponent of the design. Design 1, 2 to the exponent of 1. Design 2, 2 to the exponent of 2. What about design n? 2 to the exponent of what? Of n. It is 2 raised to the, what is the design that we are, the number there? Design 1, 2, 3, 4. Design 7, 2 to the exponent of 7. What about design 10, 2 to the exponent of 10? What about n, 2 to the exponent of n? Just like that. That is what they are simply testing you guys. So that was actually the last part of our question, all right, in this revision. So I checked other question papers, like I was working with other provinces. I'm seeing that they are just a repetition. Some of them, they are just even asking the questions, guys, as they are, like as it is, without changing, and as it is like this. So I just decided that I'm just going to end on this one. I'm not going to have those ones because it's just a repetition as it is. So use these question papers that I have for you guys to prepare yourselves, all right? You know that these are the typical questions. They are going to ask questions based on what you did in your term 1. That is why I presented the ATP for you, the annual teaching plan, so that you can see and go through the topics that are required in your term 1. And we also have those videos of each and every topic in your term 1 You just check the playlists so that you can watch the class that you do not understand. Is it about finding the highest common factor? Watch the video about that. Is it about the LCM? Watch a video about that. I have those so that you can understand all the basics before you attempt your question papers, before you do revisions. Make sure you have done all according to your syllabus, according to your annual teaching plan. So that is it, guys, for this revision. Till we meet again.